that's really being gathered by this IC, again, is material stiffness. So it's how hard that drum's rebounding off the mat. The roller location, so the GPS location of the machine itself, and the mat temperature, surface temperature of the mat. Why intelligent compaction? It's from the contractor's perspective. You may see a little bit more of a contractor twist in my presentation. That's my background. I've been with Sakai a couple of years now, but so I got a little contractor twist to some of the things I think you'll see here. Improving quality. It's a real-time visualization of the compaction process. To me, that's one of the big things. When hot mix becomes cold mix, you don't get density anymore. And with this type of system, you can see your number of roller passes. You can see the stiffness that you're getting under that drum as you roll it. You've got the opportunity at that time when it makes it still hot to make extra passes. Again, what data is collected: surface temperature, number of passes, material stiffness. In these pictures, by the way, we actually did a mini demo. Was it last year or the year before down in Waynesboro? I think it was Route 58. Just a couple display screenshots here, different manufacturers, Sakai, Omeg, Cat. So that's what the operator's looking at, especially even on our machine. I believe all the others. Right now, you see it in the center.
CCV change roll type using?
Yes. CCV changes depend on the roller you use, amplitude and frequency, and also the material used. This is current CCV, and every roller vendors have used different type of roller measurement values. Omeg is so-called using the EBI, which is kind of modulus vibration. They call it vibration modulus, and related to some kind of relative value of the modulus in the compacted. The CCV from Sakai is slightly different. It's more representative to the effective stiffness for the layer, not or this premium structure compacted.
It's a more relative term.
Yeah, it's kind of relative term that you can come. That's why we have all these doing all these correlation tests to establish kind of baseline where you corresponding to. Can I say that?
Yeah.
So they're also developing a new measurement value. I'll get to that in a minute. That I think all roller vendors don't try to answer the same question. Can I produce an index that matches exactly what you want? It's evolving technology, and this has been started back in the 1980s. Started with the geodynamics, using the roller measurement value, using the accelerometer. It's just a nerd's view of using the accelerometer vibration at the contact point of the roller and the compacted material, and flip to so-called the frequency domain, and then do all that math. That index, now we know more about that and have more experience in different projects. I think now we have enough knowledge to go to the next step to make it the final spit out roller measurement values exactly to physical values such as layer stiffness and model.
Sure.
Yes. You have a question there? You answered it. Okay. Yes.
George, so you may have already said this or mentioned this, but does the Sakai equipment that we're going to look at out there, does it allow varying either the amplitude or the frequency or both? And did you vary the amplitude or frequency or both while you're out there?
Yeah, correct. Yes. There are a couple settings on this specific double drum Sakai rollers. You can use a couple different settings with high frequency or low frequency. We normally set it about 3,000 vibration per minute for mapping, and from drum only with a low or maybe high amplitude, depending on the base we're mapping. For us, we normally set 4,000 vibration per minute with low frequency.
We switched yesterday.
Then yesterday we switched to a little bit because the structure
was 3,000 yesterday. Just because of the compaction.
Yeah, we depend on the structure.
So you do have a little bit of an ability to vary then the frequency and the amplitude on that particular machine.
I don't have a way of dealing with to take that temperature of the asphalt and use that to change our value. But that is something they're working on. But one of the contractors that wanted to use it is because he was over compacting his base. And he was saying, as guys rolling, they just wanted to make sure they had enough passes all the time. So he was running into problems of over compaction. So he changed over to this, and now he doesn't have that problem. And then we have a contractor we're working with in Florida. He's actually on a federal project. It's not a road job, it's a site job. And he's using it for all his building pads and that type of thing. And one of the things that it was funny, the first day we had it out there and we were training their operator, he would get to, his 98% compaction mark, and he would just keep going. And we would try to tell him to stop, and his comment was, they told me if I ever stop using this roller, they're going to fire me. So we did explain to him that he could stop when he got to 98% compaction. That's what they were trying to achieve there. But the other thing that it'll do, when you set your baseline up, when you're doing that proof roll, it'll know that maybe it took 5 passes to get to the compaction value you were looking for. So then when you go out and you're actually working on your base that you just laid down, and let's say you've gone 7 passes and you still haven't achieved the compaction that you were supposed to get, then it'll give that operator a warning at that point. And it'll say, do you want to keep going? Because more than likely you're not going to reach, you can roll all day, you're not going to reach compaction.
Straight. One thing, when you drop the hammer, this is a big spring in here, it'll spring it back up if you want to catch it, but you don't want multiple hits. And if you're good, you catch it. Before you miss it. But he's been practicing. I want to get further.